Okay, good morning, class. Today we're going to be working on Module 4, Lesson 12, which is solve word problems about area. So we're going to look at some word problems, and we're going to figure out the area from those word problems. And we're going to work through these together. So what are we going to learn today? So as a class, we are going to solve word problems that have to do with different areas of different objects. So rectangles we've been working on. We see rectangles every day. What are some examples of rectangles that we see every day? Well, think about in the morning. If you eat cereal, a cereal box is a rectangle, and that does have a square area. It might be small, but it still has one. What about the TV in your home? That has a square area. And then we can think bigger, like in the basketball court in the gym. That has a square area. It's much larger though, but we're working with smaller triangles. So we're going to do our fluency practice. So we're going to skip count by sixes to 60. So we have 6, we have 12, 18, 24, 30, 36, 42, 48, 54, and 60. And you can say these in your head, you can whisper them, or you can just listen. So we're going to count by 7s to 70. So 7, 14, 21, 28, 35, 42, 49, 56, 63, 70, 8, 16, 24, 32, 40, 48, 56, 64, 72, and 80. And now we're going to count by 9s to 90. 9, 18, 27, 36, 45, 54, 63, 72, 81, and 90. So you're going to ask, Miss Foster, why do we do this every time? Well, we do it for maintenance, just like a car or one of your toys. It keeps our mind sharp. Preparation, it prepares us to learn the lesson because we're reviewing our multiples. Anticipation, it helps us build skills that we use for upcoming lessons. So for this lesson, for our next lesson, we use these skills to help us figure out these word problems, to make equations. Okay, so our first one, it's basically a read, write, draw. We're gonna read it, we're gonna draw it, and we're gonna write it. So our rectangle is 6 by 9. We do not know the square area of this rectangle, but we do have our length and we do have our width. So find the area of a 6 by 9 meter rectangle. So what do we need? What equation or number sentence do we need to make in order to find out our square meters? Well, just as we have previously done in lessons before in problems, we need to put our 6 as our first number. Then we're going to take our length of 9 and put it here. Now what is 6 times 9? Well, Miss Foster, 6 times 9 equals 54. So that tells me that I have a square area of 54. On the next slide, we're going to use the side lengths of 6 by 9 to find different side lengths for the rectangle. So it has an area of 54, but what other equations or word number sentences can we use? Well, we're going to find different side lengths. So using the distributive property and the associative property, we have number 1 on our first equation, we have 6 by 9. So there's our width of 6 times our length of 9 equals. So Miss Foster, where did you get that 3 and the 3 from? Well, all I did was break down our length into 2 smaller parts because we know that 3 times 3 equals 9. So using the associative property, as we talked about before, I'm going to move my parentheses now. Well, I'm going to move my parentheses and put it around my 6 and around my 3. So that leaves me with 6 times 3 times 3. So we're going to do our parentheses first. So what is 6 times 3? Well, 6 times 3 equals 18. And then we're going to bring our 3 down. So what did we just find? Well, we found out that these 2 new side lengths of 18 and 3 still equal 54 square meters. So that means that our rectangle looks different, but it still has the same square meters of 54. So our area is the same regardless, even though the triangle looks different and the side lengths are different, it still has the same square area. So our first problem, we're going to work on this one together. So this is a new skill, and this is finding the unknown side. So the area of Carson's banner for the soccer game is 32 square feet. So we know we have an area of 32. It's already given to us. We have the area of 32 square feet. If the length of his banner measures 4 feet, how wide is the banner? So let's look at this. What information do we know? Well, we know that we have a total area of 32 square feet. We know that our length is 4. That's 4 feet. What don't we know? Well, class, we do not know the width. So we're kind of like, well, we have 32 square feet and we have 4 feet for the length. But what is our width? So how can we figure this out together? Well, what equation or number sentence can we use to solve to find the width? Well, I gave you a big clue right here. We can use division to figure out our width. So we only have 2 numbers, but we need to make sure we divide them correctly. So we're going to divide our square area by our length, and that is going to give us 8. So we now know that the missing width is 8, because if we multiply 8 times 4, we get 32. Okay, so we're going to do the same thing, but just in a different problem with a different square area. So it's called the sandbox. Brian needs to build a rectangle sandbox. So rectangle, that's what we've been working, that's a shape we've been working with an area. So here's our area. Our total area is 56 square centimeters. So we know we have our area already. It's already been given to us, so we know that. But this time we were given the width. So our width is 7 centimeters. So last time we were given the length, this time we're given the width. So does that change how we solve the problem, how we figure out what the missing side length is? Well, no, we still use the same process. So what is the length of the rectangle of what is the length of the rectangle sandbox that Brian needs to build? Well, we need to do what? Well, Ms. Foster, we need to do 56 divided by 7. And what is 56 divided by 7? Well, 56 divided by 7 is 8. So if we put 8 up here, we can check this, because what is 7 times 8? Well, class, 7 times 8 equals 56. So you're going to get to practice these in the problem set at the end for independent practice, but we're going to go through a few more. So Mary and Robert are drawing a large chalk mural, which is a big drawing for St. Patrick's Day celebration, for the St. Patrick's Day celebration at school. They draw a rectangle that is 7 square feet by 15 square feet. So we know that we have a width of 7 and a length of 15 feet. Well, that's a big number, and we just learned how to do that. So let's see what we can do to make this a little bit easier. And they need to find the total area of the rectangle so they can make sure they have enough chalk to draw. How would you find the total area? So we know our width, we know our length, and Mary and Robert need to know how much chalk they need. So they need to prepare the amount of chalk they need to build this mural. So how are we going to figure this out, class? Well, we've done this before. So, whoa, where did we get that 3 times 5? I thought the length was 15. Well, all I did is I broke down our rectangle into smaller parts. And we know that 3 times 5 equals what, class? Well, we know that 3 times 5 equals 15. So we bring down our 7, we bring down our 15. That's just another way of using a different equation to show 15, because we just made it smaller. So we know that 15 times 7 equals 105. So we know the total area of this rectangle is 105 square feet. Well, how can we show this in a different way? Well, we use the associative property and we move the parentheses. Now, is that going to change our answer? Is that going to give us a different square footage of this rectangle? Well, let's see. So we moved our parentheses. Now we have 7 times 3. And what is 7 times 3, class? 7 times 3 is 21. So now we have 21. Wow, that looks a lot different than the first one we did. But let's see. So we have 21 and we bring our 5 down. So what is 21 times 5? Well, guess what? 21 times 5 equals 105. So regardless of where we put those parentheses in this equation, we still come out with the same square feet. So 105 is our answer for this. Now, this triangle is a little bit different, but it's still the same because all we did was break it down into a smaller part. So we have 7 feet for our width, 5 and 10, which 5 plus 10 we know is 15. So it is a total length of 15, but we just broke it down into 2 smaller parts. So how are we going to write this equation? Well, we're going to do our width of 7 times our first green area of 5 feet. So we're going to write that in parentheses first. Then we're going to move over and we're going to do our 7 times 10. So how do we break this down? Well, 7 times 5 equals 35. 7 times 10 equals 70. So guess what? It equals 105 square feet. It is just a different way of expressing or of showing an equation or a number sentence that equals that same, just different side lengths. So as you can see, as we've talked about in our previous lesson and this lesson, there are different ways to express an equation or a number sentence to come up with the same area, even when the triangles look different. So to end our lesson today, I want you to think about this question. A painting has an area of 36 square inches. One side length is 9. So what is our other side? So just like we've done before, what is our other side length? How are we going to figure this out? I want you to take some time, go over this, and I want you to figure out what the missing width is. And we'll use this more in our problem set and apply the properties we've been using, the equations, and the number of sentences we've been using to find out the unknown side.